Alright, we are going to look at section 6.6 today. This section talks about solving equations with rational expressions. Now we have looked at all different operations, how to add and subtract them, how to multiply and divide them. Now here, let's go ahead and first talk about what is the difference between operations and rational equations. Now when we are talking about operations, we are basically saying, operations like sum and differences would be operations, something that you perform, whereas equations are something that you would solve. Now let's go ahead and start with some examples here. Now we will try to identify what is an operation and what is an equation, and then we'll either go ahead and perform the operation or solve the equation. So the first thing that we will start with is this example right here. Now as you can see, you have 3/5 x minus 7/10 x. So right here you can see this is an operation because you are just subtracting two rational expressions. So what we will do here is, of course, the first thing we will say is this is an operation. Okay. Then to solve this, you will first have to find your least common denominator, which would be, you can see you have a 5 and a 10 here. So 10 would go into 5, and of course 10 goes into itself. So you can use 10 as your least common denominator. Now, you will try to make both these equations have the same denominator. So you will have to multiply your first expression here by 2 so that your denominator can be a 10. So when I multiply my whole expression by 2, I end up with 6 over 10x minus 7 over 10x. Okay? So as you can see, all we did was take our first equation and replace it with an equivalent equation. I'm sorry, I keep saying equation. Replace it with an equivalent expression. And now you can see both our denominators are 10. So we can go ahead and combine our numerators or subtract our numerators. And this will, of course, give you 6 minus 7x will give you negative 1 x over 10. Okay, and you will see that will be your answer to this operation here. Okay, now let's go ahead and look at another example. Here you have 2/3 x minus 7/4 x, and that equals negative 13. Now in this case, you can obviously see that this is an equation because you have the equal to sign, and here you are going to try and solve this equation for x. So this is an equation, and just like we did earlier, we will first go ahead and find our least common denominator. Now you have denominators 3, 4, and if you want, you can think of this as having the denominator of 1. So your denominators are 3, 4, and 1. So your least common denominator would have to be 12. Now, just like we did earlier, you want to try and make each one of these denominators the same. Or what you could do, and which would help us a lot better, would be to take our least common denominator and multiply the whole equation by it. What that will do is help us get rid of the fractions, and then we won't have to worry about fractions anymore. So how do you do that? You take your least common denominator and multiply the whole equation by that denominator. Okay, so when you multiply 2/3 into 12, you will end up with, let's see, 12 times 2 would be 24. 24 divided by 3 would give you 8. So you're left with 8x. You would do the same thing for the other expression. So you would multiply 12 into 7 and divide by 4, which will give you 21x. And since you don't have a denominator over 13, the only thing you can do is multiply the 12 into 13, and that will give you a negative 156 because the sign on 13 is a negative sign. So now you can see how all your denominators are gone, and now everything is in terms of integers. And of course, this will be much easier to work with as opposed to having fractions in our problem. So you can combine 8x and 21x, which will give us a negative 13x equals negative 156. And now you want to try and solve for negative 13 equals negative 156. So go ahead and divide both sides by 13. And what will that give you when you divide negative 156 by a negative 13? And you will see you will end up with x equals 12. Okay. So in our second example here, this was an equation. Okay. We went ahead and found our LCD and then solved our equation, and we ended up with x equals 12. So you will say your solution set is the number 12. Okay. Now if you want, you can try and check your answer. And for checking your answer, just start with the original equation and replace these x's with 12 as you found your solution. So let's go ahead and see what happens when we check our answer. You had 2/3 x, so 2/3, instead of x you will write your 12, minus 7/4 x, again replace your x with a 12, equals negative 13. And let's see, this will give us 8 minus, again go ahead and multiply this, 21, which equals negative 13. And you will see you end up with a true statement here. So that tells you that 12 is the solution to our original equation. Okay? Alright, so let's summarize what we did here. Now, remember, when adding or subtracting, the least common denominator must be kept throughout the simplification. So basically, in our first example, as you will see, we were subtracting here, and our least common denominator stayed throughout the process as we were simplifying this problem. Okay? For equations, when you're solving an equation, the LCD is used to multiply each side so that the denominators are eliminated, and that's what we did here. When we multiplied by the LCD, the original equation, we got rid of the fractions, or basically we got rid of the denominators, and everything was just in terms of integers. So if you keep this in mind, you should be able to perform the operation or solve the equations pretty easily. Again, with operations, you keep the LCD throughout the simplification. With an equation, the LCD is used to multiply each side of your equation so that you can eliminate your denominators.